So hi everyone, today I'm going to discuss about indefinite integrals. This is the beginning of a new section because previously we have learned about differentiation. Now we are going to start our second step. It is called integrals. So integrals have two categories. First one is definite integrals and second category is indefinite integrals and definite integrals. So today I am going to discuss about indefinite integrals. So this is our topic. Uh, so first let's see what is the idea of the antiderivative. So especially if we are given some function, we know how to find the derivative of the given function. But basically if we are given the derivative of a function, how we can find the original function? For this process we call it as integration, or sometimes we use the word anti-derivation, but this word is not a very common word. We usually use the integration. Let's see some example. So if the derivative of a function is 2 times x, we know we have to find what is the original function. So from previous experience, we know if fx is x square, then after deriving this x square we can obtain 2x. So derivative is 2x, so original function must be in the form of x square. But function could also be in this form, fx is equal to x square plus 4, because we know this 4 is a constant. By taking derivative it becomes 0. So generally x square plus 4 is the antiderivative of 2x, but x square plus 5, x square plus 7, so any value we can use for this one. So after that we use this as a constant, so you can see it. So it is clear that any function of the form fx is equal to x square plus c, where c is an arbitrary constant, so typically we call this as a constant. Then by taking the derivative of this x square plus c, we can obtain f prime is equal to 2x. So antiderivative is x square plus c, and here c is an arbitrary constant. So the process of finding an antiderivative is also called integration. So finding the antiderivative, or in other words, if we are given a derivative of some function, so how we can find the original function? So for this process we called as integration, or sometimes we use indefinite integrals, but mostly we use the word integral. So this is the notation. So this sign, we call this as the integral sign, and integral of fx dx. So this is some example. Integrate 2x with respect to dx. So if we integrate 2x with respect to dx, we call it, answer is x square plus c. From previous problem we know it. So if f prime x is 3x square, what is our original function fx? For this process also we need to integrate this f prime x. After integrating this f prime x with respect to x, we can obtain our original function. It is x to the power 3 plus c. So in always when we are writing our answer, we need to add a constant. So in this indefinite integral section, always you need to write a constant for your final answer. Let's see. So first we learn about powers of x formula. This is the given formula. If x to the power n may be some value, but it is not equal to -1, so this is important. If we integrate this one, our answer is this one, x to the power n plus 1 divided by n plus 1 plus c. So move to this example. So you need to solve this problem. Integrate x square with respect to dx. So here first we use to compare with our problem with your formula. So we know this is our formula. So here first you need to understand what is your n. So it is 2. So now you can start. Only thing you need to do is you need to substitute 2 for this n in here. Substitute 2, then you can obtain x to the power 2 plus 1 divided by 2 plus 1, because it is x to the power n plus 1 divided by n plus 1 plus c. So by simplifying this one, we can obtain x to the power 3 divided by 3 plus c. This is the basic level. Now let's move to our second problem. So you need to solve this one. Cubic root of x is our function, then you need to integrate this one with respect to x. So here first you need to compare with this problem with your formula. This is the formula. So if you got this problem, you can see this cubic root, we can write this as x to the power 1 over 3. So your n is equal to 1 over 3. So now you can use this formula. So you need to substitute 1 over 3 for this n. So it becomes x to the power 1 over 3 plus 1 divided by 1 over 3 plus 1. So it is x to the power 4 divided by 3 divided by 4 divided by 3 plus c. This is another example. So you need to integrate this one. 1 over x to the power 2 dx. So here you can write this as like this way, x to the power negative 2. So here your n is negative 2. This is your n. So by using this our original formula, you can write it as negative 2 plus 1 divided by negative 2 plus 1 plus c. So finally it becomes negative 1 divided by x plus c. So these are few examples. If you are given x to the power n function, how we can find the integral. Now we are going to seek some other properties. Let's see it. So especially these formulas will be useful in evaluating integrals. The following table shows how some new integration formulas result from differentiation formulas. So first one is, we know if we derive x with respect to x, it is 1. So if we integrate 1 with respect to x, it becomes x plus c. And secondly, here c is a constant. It may be 5, 4, 3, negative 6, 7 divided by 2, anyway a constant value. So we can take this constant out of the derivative. We have already followed it. So when you are doing integrals also, if some function have multiplied with the constant, we can take this constant out of the integral sign. Third one is, we know, we call sometimes it as summation rule. Ux plus or minus bx is equal to u du over dx plus or minus dd over dx. So this is happening for the integrals also. If we integrate u plus v, then we can write integral u plus integral v. Also u minus v, we can write it as integral u minus integral v. So we can distribute, if it is a summation, if it is a reduction, we can distribute and we can write it as separately two pieces. Now let's see some examples. So first you need to evaluate this one. So if you look at this problem cautiously, you can see this 4 is your constant c. So we can take it out of the integral sign, then do the normal process. You know how to integrate this one. So integral of 1 is equal to x plus c. So already we have constant, so we have to multiply by this function. So it becomes 4 times x plus 4 times c1. So again it becomes a constant. So finally your answer becomes 4 times x plus c, because 4 times c1 is also a constant. Multiplication of two constant is also a constant. Second one is this one, 8 times x to the power 5 dx. So 8 is a constant in here. You can take it out of the integral sign, then integrate this x to the power 5. Then it becomes like this way. So here 5 is our n. So here x to the power 5 plus 1 divided by 5 plus 1. So it is x to the power 6 divided by x to the power 6 plus c1. By simplification we can obtain this result and then move to this problem. So clearly you can see this is summation of two formulas. X to the power 3 is one function, it is v, and this is your u. So now you can write it as separately. Integrate u with dx plus integrate v, here integrate v with dx, and here integrate u with dx. Then do the integral separately. X to the power 4 divided by 4 plus c1, and from this integration we can obtain here 4 is a constant, take it out of the integrals, so x to the power 1, so your n is 1 in here. X to the power 2 divided by 2 plus c. By doing all the simplifications you can obtain x to the power 4 plus 2x square. Here also c1 plus c2 is again a constant, because we know summation of two constant is also constant. Then this is the final result. So now let's move to some application problem. First you are given the marginal revenue, so we know if we derive the revenue function we can obtain the marginal revenue. So a specialty in this problem is you are given the marginal revenue and they ask to find what is the original revenue function. So we have to do the antiderivative process. It means if we integrate marginal revenue we can obtain revenue function. Okay, let's move to problem. Sales records at Genesis Technologies show that the rate of change of revenue, this is the marginal revenue, in dollars per unit for a motherboard, this marginal revenue is 300 minus 0.2x, where x represents the quantity sold. Find the total revenue function for the product, then find the total revenue from the sales of 1000 motherboards. So first you need to find the total revenue function. We know the marginal revenue can be found by differentiating the total revenue function. So now we need to do the inverse. It means if we integrate this marginal revenue, then we can obtain our original revenue function. So here we have started. So if we divide margin, if we integrate marginal revenue, it becomes revenue function. Then integrate this one, take it separately, so this one and this one, two separate pieces. Think it is, this is your u and this is your v, so this becomes 300 times x, and this becomes here x to the power 1, so n plus 1 means 2 divided by 2, so it becomes 0.1 times x square and plus c. So here we can use k is also a arbitrary constant. Now we know this is our revenue function, but the problem in here is we don't know what is the value of k. So by using some initial condition we can find it. So when the fact that there is no revenue when no units are sold, so when x is equal to 0, revenue is also equal to 0. So use this fact. So it means when we haven't sold any item, then revenue is also 0. In this point it means 0, 0 point. So by substituting you can obtain, setting x is equal to 0, then it is r is equal to 0, it gives k is equal to 0. So your total revenue function is this one. In the problem it is further asking find the total revenue when 1000 motherboards are sold. So only thing you need to do is substitute 1000 for this revenue function, then you can obtain it is $200,000 we can obtain as a revenue by selling 1000 motherboards. So okay, thank you everyone. From next video I shall come on